Hello everyone, I am Uttam Satpute, Professor Electrical Engineering Department at Dr. D.Y. Patil Pratishthan's College of Engineering, Salunkhe Nagar, Kolhapur. This is the video on traction moment and energy consumption of the subject electrical generation and utilization of 8th semester. In this video, we will particularly concentrate on speed time curve. This is a very important aspect of terrain movement and energy consumption. This is the center of focus of this chapter. So, if you understand speed time curve, we can understand what is the distance covered by the train, what is the energy consumption, and the dynamics of the train, and also we can find the rating of the machine, motor, etc. So, let us understand first the speed time curve in this video. So here it is shown the speed time curve of a typical main line service. Uh, Now let us understand the speed time curve, what all parameters it indicates. So we can see on the x-axis we have time in seconds, and on the y-axis it is speed in kilometer per hour. Okay, so from kilometer per hour, we can convert it to meter per second. I will let you know later on. So here you have to understand that it shows the relation between the speed of the train or the vehicle with respect to it time. Now, here from the start point to the end point, so the train undergoes various phases. So it shows all the three phases. So the first phase we can see here, it is the acceleration phase. So 0 to t1, this is the acceleration from 0 to t2. Actually it is the initial phase and it is divided into two aspects. So you can see the first phase here, it is acceleration. So it is from 0 to t2. It is, and this initial phase again it is subdivided into two. The first 0 to t1, it is called as constant acceleration, okay, or acceleration during notching up. Then the second phase from t1 to t2, it is called as speed curve running, or called as acceleration on speed curve. Then the third phase, that is second phase, it is from T2 to T3, it is called as free run or constant speed. Then from T3 to T4, it is called as costing phase. And from T4 to T5, it is called as braking phase. So what is these phases all about? These phases will make one cycle. So the train undergoes this cycle repeatedly between 2 points, or between any stop and start and stop. Okay, so now let us understand it one by one. What is this? Okay, so now I'll just so from 0 to t1, this is called as constant acceleration. Okay, so as we know that during the start, when we start the car or maybe bike, it is in the first gear. In the first gear, it is the initial phase, during which the vehicle accelerate, and the vehicle moves with a constant speed. And when it moves with a constant speed, we can say the acceleration is constant. So we can see here, this is the phase. So I will tell you in terms of this. Okay, so here let us understand this. So this is something like this. So from 0 to t1, this is the phase where the speed is increases linearly. So the speed is increases linearly, and we know that acceleration, it is given by rate of change of speeds. It is given by dv by dt. So, but accelerate, because the velocity is constant, so we can say the acceleration is constant during this phase, because this is v of t, it is increasing linearly with respect to time. So this is increasing linearly with respect to time, so that acceleration differentiation of this a linear function, it will become a constant. For example, suppose if I take v of t, it is equal to say 30t. So velocity is increasing at the rate of 30 with respect to time. The differentiation of 30t, it will be 30 only. So it is a constant. So why it is constant? Why it is called as constant acceleration? It is because during this phase, that is when it is from the start, then the velocity increases linearly, and during this phase, the acceleration is constant. Now, in terms of power, suppose if you want to find what is the power that is drawn from the motor during this phase. So we know that F, that is a force, it is given by mass into acceleration. Now the mass during this phase, we can, if we assume constant, then acceleration, it is becomes constant. So the force is also constant. And if the force is constant, the power, which is actually the rate of doing work, so we can say it is dw by dt. Now work done, the work done, it is basically given by force into distance. Force into distance, this is with respect to dt. We can see now that now the work done, it is force into distance, so it is also linearly increasing, because how you find a work done in a simple way here. The work done, I'll just give you one simple equation. Work done, it is equal to force into distance. So force is almost constant. Distance, it is increasing linearly. You can say increasing. It is increasing. So the work done, it is also increasing. Basically, this area under this curve, which will give you the distance covered. So the distance, it is the area it is increasing, uh, and because of that the work energy. Now in this case, suppose if this is, for example, suppose uh, okay, I will later on we'll come to this aspect, what are how to find the distance and all. But here let us understand the work done is force into distance, and differentiation of work done gives you power. So the power, it is constant during this phase. So you can relate, if the acceleration is constant, the power is constant. So what is the point to be remembered during this phase 0 to t1? It is the initial phase of the train where the velocity is increasing linearly, and because the velocity is increasing linearly, the acceleration is constant. And because the acceleration is constant, the power that is drawn from the motor to drive the train, it is also almost constant. Okay, now the next phase, you can see here what is the next phase. The next phase, it is called as speed acceleration, acceleration on speed. So during this phase, we can see that the velocity is slightly decreasing. You can see it is decreasing during this phase. When after second gear, almost when we start when the first gear is, then when you put second gear or third gear, then the vehicle will have some moment, and during this phase, even the velocity is increasing, but the acceleration, it will decrease. So I will just let you know in this diagram here. So next, during this phase, from here you can see here, this is another phase, in another phase of initial. So from 0 t1 to t2, during this period, this is called as acceleration. It is called as, I think, it is called as acceleration on speed curve. So during this phase, Okay, during this phase, the acceleration. So here you have to remember that the velocity it is increasing obviously, but the acceleration it is slightly decreasing, and it becomes almost zero at this time t2. How you find the acceleration? Acceleration is actually the slope of this. Suppose if you take slope of this point, then we will get the acceleration. Now when the train moves at its peak speed, then the its slope here it becomes totally zero. So the acceleration it is decreasing from t1 to t2, and because the acceleration is decreasing, the power is also decreasing. The drawn that is drawn from the motor, that is also decreasing during t1 to t2. It is because of the motion, because of the moment of the vehicle, that the train, the acceleration it will be decreasing and the power it will be also decreasing. Next phase, it is called as free run. That is from T1 to T3, the train moves at constant velocity. The train moves at, it moves at constant velocity. And when it moves with the constant velocity, the acceleration is zero. Now you will ask that if the acceleration is zero, then the power that is drawn from the motor, it will be also zero. Yes, no, it will not be zero. It will be, the power will be drawn from the motor only to overcome the resistance. It may be due to resistance, maybe due to wind, or maybe due to gravitational, or it may be the friction between the rail and the train. So it all no power is drawn for acceleration, but the power is drawn to overcome the other forces that are opposing the train movement. So during this period, the acceleration is zero, and the power it is it is also zero. That is only for acceleration. Then the next phase T2 T3. So the next phase it is called from T2 T3 to T4. It is called as coasting. Coasting. During this, the power is during this it is called as free run. You can say it is called as free run. The power is drawn, no power is given to the train. It moves by its own inertia because of its speed. So it is called as coasting period. Then the next, during this, there is no power drawn. Entirely, no power is drawn from the your this one from the motor. And here from the next, it is braking. The next phase from T4 to T5, it is called as braking phase. During this, the brakes are applied to stop the train. So you have to understand this speed time curve, like a typical team speed time curve. So you have to understand what it shows. It shows the velocity with respect to time, and it undergoes, the train undergoes the various phases. So it is called as initial phase, then it is called as free run or constant, then it's called coasting, and then braking phases. So during these phases, the vehicle moves at different acceleration, and because at different acceleration, the power drawn from the motor it will be different. So this is a typical speed time curve, what you have to understand. Now, what is the use of this speed time curve? So speed time curve will be very helpful to find out the so you can uh, the first thing, it will tell you how the train is moving with respect to time, at what speed it is moving. That is the first point. The second point, it will give you the speed distance, how much distance it is covered by the vehicle. So how you find the distance from the speed time curve? Just I will give you one simple concept. Suppose from zero, when the vehicle is started, from suppose in t1 time, this from 0 to t1 time, if the final velocity it has reached to v1. Now how you find the distance from the speed time curve? Now the area under this curve will give you the distance. So d1 distance, you can give it, it's like this is the area of a triangle, half b into h. So half into base, the base it is this T1, and height, you can see this is the height, which is V1. So it will give you half V1 into T1. So this will give you the distance covered by the train during the phase 0 to T1. Suppose if the vehicle is moving with a constant, say if it is moving with constant velocity or something like this. Suppose if the vehicle is moving with, this is during free run. So suppose from T2 to T3, if it is moving with constant speed, say V2, then what is the distance covered? Now this area under this curve will give you the distance covered. So the distance covered, you can say it is the area. Area, it is base into, this is a rectangular, so you can base into height. You can take, so the base, it is this time. So it is from T3 to T1, T3 to T2 into the height. You can say it is V2. So this is the height V2. So this will give you the distance covered by this train during T2 to T3 when it is moving with the velocity V2. Okay, so similarly, if during suppose if it is a braking period, something like this, from say T4 to T5. So if this is the speed V3, then again you have to use the area of the triangle equation, that is half B into H, and B, now it is T3, T5 minus T4, and height, it is V3. So this is the distance covered. So by finding the area under the speed time curve, we can find the distance covered by the uh, by the uh, by the train. Okay, now I'll just show you, and also you can find the energy. Later on, we will see how to find the energy. Now, these are some typical speed time curve of urban city service. Urban means metros. This is the simple example I can give. Metro is the best example for urban. And the next service, it is suburban. Suburban means you can take local trains in Mumbai is an best example for suburban services. And then main service. So the main service you can take, it is like your Vande Bharat or Rajdhani Express. So they are your main line service. Now, how you differentiate? What is the speed time curve of these type of trains? So yeah, this is the speed time curve. Here it is given. This is a speed time curve of urban service. So basically, just I want to give you the distinction between this in a small this thing. I will not elaborately. You can read it, but just I will give you the differentiation. So suppose if it is an urban, I'll give the best example is metro, in metro trains, and suburban. The best example for suburban, it is your local trains. Okay, in Mumbai and some. And then we have main service. The main service, the best example is Rajdhani Express or Vande Bharat or like that. Now, what is the main difference between these train? We can take in terms of the distance between the start and stop points. Then you can take the acceleration and the braking, and then you can think about the next one is uh, just wait a minute. I'll just take it from here. Okay. Uh, okay. Now in the urban, the distance is up to 1 kilometer. The distance is very very short. Okay, and because the distance is small and it has to cover in very short time, the acceleration and braking is very very high. It is very very high. Okay, and you can take an example of, as I said, metro. Then local train here, the distance is little bit up to 5 kilometer, up to 5 kilometer, 1 to 5 kilometer. So it is from 1 to 5 kilometer. Distance is little bit more, and here uh, the acceleration and braking is moderate. It is not that, it is not moderate. What about free running? Actually, here I will write free running also, but you can understand free run phase. So in the urban, the free run is very very short. It is very very short. Almost it is not at all available. It is not a very 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 short phase, or sometime it is not available. Moderate, it is little bit available. Free run is very very little bit available in the free run. Whereas in case of main service line, the distance is up to 10 kilometer between the two stop points. And what about the acceleration and braking? It is very low. The trains, you can see the main service line, they go very slowly, and they during braking also it will be very low. But free run, it is very very high. You can say free run is almost a very high phase of free run for this main service line. So here it is given typically this the difference between the various urban, suburban, and main service lines. So in terms of acceleration, also, and retardation. So we can see here it is very very high in case of urban acceleration, where it is low in case of main service lines. Okay, so this much in this video. So this is a very very important aspect, speed time curve. In the next we will go to the energy consumption and other dynamics of the train. Okay, so thank you very much to you all.